All right, guys, today we've got the last section in chapter 7. So section 7.7, the title is called differential equations. Okay, what's a differential equation? It's just an equation that has a derivative in it. Okay, and what we're going to be doing is we're going to solve the differential equation. Okay, what does that mean? We are, I should say you are finding, sorry, that looks better. You are finding an equation for y in terms of x. Okay, so there's going to be a derivative in it. We kind of want to go back to the original. You are finding an equation for y in terms of x. Okay, and then just really, we're going to go right to examples. We're going to go ahead and solve the differential equation. We're going to go back. We're going to take the equation that has the derivative in it and go back to y equals. Okay. The only kind of note part is don't forget that sometimes you can write the derivative of y like this, but this time we want it no matter what. Sometimes it'll start out like this. If for some reason it turns into this, or if it starts like this, the first thing we want to do is change it to dy dx. Remember, that is the derivative, dy dx. We just kind of take short notation, or we just write it usually like this. But for today's lesson, we're going to want all derivatives dy dx. And most of them actually start like that, but just in case they don't, the first thing you want to do is change it. All right, let's take a look at our first example. So the first one says the derivative of y equals x squared over y squared. Okay, so in this case, the very first thing we're going to do is we'll go ahead and change this to dy dx, okay, and it equals x squared over y squared. All right, so the goal is to get everything with y's on one side and everything with x's on the other. And this is usually how it's written, so it's kind of nice if you just cross multiply, right? All the y's will be together and all the x's will be together. So let's cross multiply, and we would get y squared dy equals x squared dx. And that's exactly what you're looking for. As soon as you have that, then you want to take the integral of both sides. Once we take the integral of both sides, all right, so we have add 1, divide by the new, so 1/3 y to the third, and the dy goes away because we want y in terms of x, so we're in good shape. Now technically, for this one, let's talk about it, it's plus c, right? And then this one, the same thing, add 1, divide by the new, we get 1/3 x to the third plus c. But the first thing you're going to do is you're going to combine these c's. So we could like call this c1 and c2. But the very first thing you're going to do is, let's say you're going to move this c1 over and get another c value. So you don't have to put it on both sides. Technically you are, but the very first thing you're going to do is move it to one side. So from now on, I will just put it with the side that has the x. Not that we're ignoring the y, but the very first thing we would do is take the one that is with the y and move it over. And this is just another constant. Okay, so we're just going to do plus c. Okay, then we're in good shape. Let's see, can we see? Okay, so let me slide it up, though we're running out of room. Now we're solving for y. Solve for y, and it'll be in terms of x, and we're in good shape. So multiply everything by 3. So that goes away. We get y to the third equals, we'll distribute that 3. So let's talk about distributing the 3 too. When we distribute the 3, that's not too bad. That just goes to x to the third. That's actually really nice. When it goes here, it's just going to become another constant. We usually don't write 3c, even though we could. It's just because it's another constant, we just kind of keep writing c. So technically we are distributing it, but 3 times c is just a constant, so we just put the c there. All right, we're solving for y, so we want to take the cube root, and there's our answer. Y equals, make sure you can see it, yep, it fits on this page, the cube root of x to the third plus c. Okay. All right. right, let's try another one. So the goal is y is on one side, x is on the other. Take the integral of both sides. Okay. All right, let's try. This one is x, y to the fourth, derivative of y, equals 3x plus 7. Okay, so right now, oh, first thing we want to do, this one is still like this, right? So we want to change that. We're going to do x, y to the fourth. We're going to write dy dx. 3x plus 7. Okay. So really, we have our y to the fourth and dy on the same side. So let's get rid of the dx. Let's multiply both sides by dx. Use a different color here. Let's so I'll multiply, I'll squeeze in a dx here, and then we'll multiply and put a dx there. Okay. All right, so those cancel nicely. So we've got, I don't know, does the orange show up? Hopefully it does. X, y to the fourth equals 3x plus 7 dx. Okay. All right, and then the last step is to, well, I shouldn't say last step. We got a few steps to go, don't we? We want to, oh, but I forgot my dy, didn't I? Don't lose that dy, that's important. Let me put the equal sign. This dy is still there, it's not going anywhere. All right, so let's divide by x. And so, okay, now let's make sure we get that in there. Y to the fourth dy equals, and we can, technically we're dividing this whole thing, but we can actually just split it up here. So we can do 3 plus 7 over x dx. It's kind of like, right, if I had like 12 times 5 over 3, it would be okay just to do this situation. So that's what I'm doing here. Because this is multiplication, we can get away with a lot of stuff. I can just simplify this right here as if I did it right here. Okay, even though that times 5 is still there, it is okay just to simplify this stuff. Okay, so that's good. Yeah, just make sure I didn't lose that dy, so we're okay. Now look, guys, we're in great shape. We've got all our y's on one side and all our x's on the other. Perfect. So what do? That's our whole goal. Take the integral of both sides. Okay. All right, so this one, it gives us what? Add 1, divide by the new, 1/5 y to the fifth. Okay, this one we're going to have to do in pieces. So the integral of 3 is 3x. What's the integral of this guy? We haven't done that for a while. The 7 is kind of like a coefficient, so that just stays. And then the integral of 1 over x is ln x. Okay. Technically plus c on both sides, but I would move it over. So I just kind of have this plus c now floating around. Okay, so we haven't done that for a little while, but now we're good. We integrated both sides, multiply both sides by 5. So that gives us y to the fifth. And this gives us what? 15x. This would give us plus 35 ln x. And again, this is just another constant, so we just kind of keep it floating around as plus c. Technically maybe it would go from c sub 1 to c sub 2, but at the end of the day we just write c. Good. All right, and then to get y by itself, take the fifth root. Okay. So y equals, and then it's just this messy thing, but the fifth root of 15x plus 35 ln absolute value of x plus c. Remember, if we don't know for sure that this is positive, then we need to put those absolute values. If we know for sure this, like if it was x squared, then we wouldn't need the absolute values. Good. Okay. We're cruising, guys. All right, let's try. All right, let's try. All right, let's try this next one. How are we doing? Hopefully okay. If not, email me. All right, we'll keep in touch. Don't hesitate to email. All right, this one starts out dy dx. So this one actually starts out dy dx equals 5 times the cube root of x over e to the y. Okay. All right, so maybe a little bit harder, but they already wrote it dy dx, okay? And it's kind of nice when it's one fraction and one fraction. Chances are all you have to do is cross multiply. Okay, so if we cross multiply, we get e to the y dy, and it equals 5 cube root of x dx. And that's it, right? We're ready to go. We got all the y's on one side, and we got all the x's on the other. So as soon as that happens, take the integral of both sides. Okay, remember, we're trying to see what the original equation looked like to create this derivative. Okay. All right, so this guy, integral of e to the y is e to the y. Okay, technically plus c, but we'll just kind of put it all on one side here. Maybe this one we're not ready to go. I mean, some of you could actually do it, but maybe we should take the time to rewrite it. 5x to the 1/3. Okay. All right, so e to the y, remember plus c, but we'll just stick it on this side. Okay, now I think we're ready to go. So we're going to add 1. That takes us to 4/3, and then divide by 4/3 or multiply by 3/4. Okay, and then the plus c. So if this was plus c, we would just subtract it over and put all our c's together over here. Okay, so now we've got e to the y equals 15/4 x to the 4/3 plus c. Okay, so now the question becomes, and there's a couple ways to look at this, but we have to get y by itself. So this is just old arithmetic. One way to do that is take a natural log of both sides. Why would I take a natural log of both sides? Let me get it written down. You think about it. Let's see, and that actually is with the natural log. So that actually looks like that. What's the whole point of taking a natural log of both sides? That exponent rolls down in front. So if my variable's up high, always think of taking a log of both sides, especially if the base is an e. You might as well take the natural log of both sides, though we've kind of been doing that anyways, but you definitely match it with that. So take a log of both sides so the y can roll down. Okay. And then we're in good shape. And this guy, finish this off. What happens here? E to what power gives me e? E to what power gives me e? This is 1. ln of e, if you type it into your calculator, that's 1. So we really have y equals ln 15/4 x to the 4/3 plus c. Okay. All right, let's do one last one. Okay. So we're going to do the same thing, and it actually looks pretty straightforward. So we're going to do dy over dx equals x to the 3rd over y. But they're going to give us an extra piece of information. I think this is like the second problem on the homework. Y of 2 equals -8. Okay. All right, so we'll save that for the end. This, does anyone know what the purpose of this is? The purpose of this is we can actually figure out what C is. So if you have that, you can actually figure out what C is. Now also be careful on the homework to separate these two. They put a comma, but it kind of looks like a derivative. When I was looking at it, I was like, oh my goodness, we have two derivatives, but it's just a comma. So don't let, I don't know why, when I was looking at the computer, it looked like somehow that comma was a derivative. So just make sure you understand for that, I think it's problem 2, that's just a comma to separate this. Okay, all right, so let's go at it. We're just gonna cross multiply. dy times y, I'll put the y in front, equals, and then let's do x Can we see okay? X to the third dx. Okay. So that part looks really good. We're ready to go. All y's on one side, all x's on the other. So we'll take the integral of both sides. This one is what? Add 1, divide by the new. So 1/2 y squared, technically plus c, but we'll just put it all together with on this side. Add 1, divide by the new. So we've got 1/4 x to the fourth. And then we'll officially do the plus c over there. Okay. All right, 2 steps, right? So we're going to multiply both sides by 2. Make sure you guys can see okay. So that gives us y squared equals, we will bring the 2 in here. So instead of 2/4, it'll be 1/2. We'll just reduce it. And then yes, it goes to the c, but because that's just a constant, we just usually just leave it as c kind of floating around there. Okay, now this is where it gets, there's 2 ways. This gets a little dicey and then this gets a little dicey. Every other time we've had this as an odd exponent. When this is even, we really should, so we have to take the square root, right? To undo a square, we're going to take the square root. We really should do plus or minus because we're not really sure. Most of the time we do assume the positive, but technically if we put in that, we should do plus or minus. Okay, so now this guy comes into play. When x is 2, this is x, when x is 2, the function, or y, equals -8. Okay, so when x is 2, my y value is -8. -8 equals, I'm going to leave this for a second. Let's go ahead and put in 1/2. We'll do 2 to the fourth plus, and now I can go find c. Okay. All right, why did I leave this blank here? It's got to be one of these because it's a function. Which one is it? Well, if my answer is -8, the only way for this square root to get a negative answer is that I was really using the negative in front. Okay. So look for that on the homework. Our book likes that. I tried to just do one with positive, but the only ones on WebAssign involve the negative. So it's probably good to a reminder that technically it's plus or minus. And then if I know my answer is -8, that means it had to be the negative one. That's the only way for y to be negative, right? This square root is not producing a negative, but there could have been a negative out in front. This is kind of like solidifying, I guess you'd say, that this is in fact negative. Or I'm sorry, this is solidifying that this is in fact negative. All right, so let's, okay, so now we got to solve this for c. So this is my answer. So I even know this. Now I even know this, but my answer is -1/2 x to the fourth plus, now I just have to go find c. Okay, so let's go do that. -8 equals negative square root. This would be, what, 16 divided by 2. So this just happens to be 8 as well, and then plus c. All right, so technically we could divide by the -1. So we have 8. And then we've got 8 plus c. We have to undo the square root, so square both sides. Right, because my c is under that square root, so square both sides, so 64 equals 8 plus c, and then subtract 8. What are we doing space-wise? Okay, I'm going to slide it up. Oh no, and our lights went out. I don't know if that made a difference. Let me see if I can get the lights to come back on. There we go. All right, oh my goodness. Good times, good times. All right, so 64 minus 8 takes us to what? 56 equals c. Okay, so now I can go back. We kind of already determined that it was the negative, and now my c is 56. Okay, so there'll be one of those. I think it's problem 2 actually, where they give you that information. That just tells you once you have your answer, you have to go find c. Okay, Good. Okay, we're gonna stop there. Oh, well, we're short. Yeah, that'll be good enough. I guess we could have done the word problems, but you know what? For this year, we're just gonna not do the word problems. So I'll email that to you. I think you can skip. I'll double check. I think you can skip 6 and 7. So see if you can do. Oh, wait a minute. Let me see. Do we have to do one more? I think that'll be okay. All right, I'll double check and then I'll email you guys, but that should be good enough. At least you get the idea of what a differential equation is, and you get the process of how to go back and just solve for y, take an integral of both sides. All right.